Jared Forsyth. I work on the mobile team at Khan Academy, so I spent a lot of time in Java and Objective-C and Swift. But my roots are really in the web, and so I spend all my personal projects are working with React. And I keep pushing to get us onto React Native in our mobile apps, but we're not quite there yet. But so in our Android apps and our iOS app, we use observables a lot. And there are all kinds of asynchronous queries that we do, and this happens on the web as well. And one thing that I've always wondered is, how do these things relate? You've got observables, and then there's promises and callbacks. And if you've ever heard of core.async or CSP, they're all different ways to try and attack this problem of dealing with asynchrony in languages that are essentially non-asynchronous. They're synchronous. You execute one thing, you execute the next thing after it. So here are the 4 things I'm going to be talking about. Callbacks, promises, and async await is just kind of a nicer syntax on top of promises. And then observables. And when I say observables, I mean the ReactiveX observable, RxJava, ReactiveCocoa, RxJS. And then communicating sequential processes, which everyone says CSP because that is way too many syllables. And this you might be familiar with from the Go language, the Go blocks, or if you are a Clojure or ClojureScript person, the core.async brings that to Clojure. And there are a couple of libraries for Python and for JavaScript that also give that to us. So why should you care about this? You know, in the good old days of JavaScript, you don't have to worry about asynchronous stuff. If you wanted to input from a user, you use prompt. And then it pauses the whole browser, like all of the tabs stop. And then wait for the user to put in their name, and then you can just keep going. You had synchronous AJAX requests. It was great. But even then, there were event handlers. There were asynchronous network requests. And then along came Node, and there were all kinds of asynchronous things that we had to do. There was file access, networking, databases, and all of a sudden, the callback paradigm that we were used to from the web started to be used a lot more, and we developed the error-first callback pattern so that we could account for errors in callbacks. And when I talk about callbacks throughout this talk, I'm mostly talking about the error-first pattern. And then now, in the modern web, we have animations, we have web workers, we have IndexedDB, all kinds of things where we're going to have to deal with asynchronous processes. And in many cases, we have to coordinate them. So first, I'm going to give an overview of these 4 different ways of dealing with asynchronous stuff. Callbacks, I'm talking about error-first callbacks from Node.js. The contract, the implicit contract, is that they're only called once. I don't know if you've ever had a library that breaks that and then everything falls apart. This is an example of what you might do with callbacks in Node. You read a file, and then you do a network request, and at the end, you've got these 2 bits of data. And you need to make sure to handle all of your errors. So if error, do something. I'm not handling the errors very well here, but I am handling them. Promises. Promises are different from callbacks in that they cache their result. And they enforce that there's only ever one value, which can be really valuable. The thing that has been super annoying about promises ever since they were introduced to JavaScript is that they eat errors for lunch. Like, if you've ever tried to use a promise and then something doesn't work, it manifests itself in different ways, but somehow you have this niggling sensation in the back of your mind that somewhere a promise has eaten your error and you don't know where it is. And so you go through, you put breakpoints, you do whatever. These days, things are getting a little bit better. I saw actually yesterday that Node version 7 is deprecating this error-eating behavior. So unhandled promise exceptions will kill your Node process in the future and give you a proper traceback. So in the somewhat near future, this will no longer be a problem. And modern browsers also allow you to catch these exceptions when you're debugging. But this is what the same code would look like if you were using promises. You've got a promised version of reading a file and getting a website, and then you can do something at the end. And the catch clause will be called with any errors that happen from either of the promises, and you can handle them there. Async await, as I said, is just kind of a prettier way to use promises. The underlying idea is the same. Async calls return promises. And now in Chrome 55, which is in beta, async await is natively supported, which is a huge thing. If you've tried to use async await with transpilation via Tracer or Babel, debugging is just a nightmare because the resulting state machine is so different from the code that you wrote, especially if you have source map turned on. You have no hope of figuring out what the errors are. This is what that code would look like if we turned it into async await. And you can see there's less nesting. It's easier to keep track of variables within the same scope of a function. But again, make sure you catch those errors. Moving on to observables. Observables in CSP work on multiple values. And so there's a lot more going on, a lot more power. And the underlying principle of observables is a stream of values. You never really work on one value at a time. All the transformations that you do take in a stream and return a new stream. And it's immutable. You're not mutating the original stream. You get a new version that has been transformed, either by mapping over everything, by filtering, by cutting the stream in half, starting late, ending early. And this is an example of code that has only been slightly modified from where it is in our Android app, actually. There's a page where you can do math problems in the Khan Academy app. And math problems are grouped into a sequence that is called a task. And so here, we need to get the task data. This is for setting up this exercises screen. You first need to get the task data, and then you've got a stream of these problems. And with the first problem, we want to combine it with the task data and load that up. But then all the subsequent problems, we want to do something else. It's a simpler process to just swap in a new problem. We don't need the task data. And you don't have to understand all of this, but this is just to give you a feel of what it's like to work with observables. CSP doesn't use streams as a concept. Instead, you're working with each value individually, which is a very important difference. And there are lightweight threads. Again, if you're familiar with Go, the Go threads, where when you send a value to another process, you block until they accept it. And when you ask for a value from another process, you block until they send it. And so there's coordination that goes on. It's very different than the way that observables work, where the producer just kind of starts putting out values as soon as they get subscribed to, and the subscriber handles values as they happen. It doesn't wait. It doesn't have a way to block the producer unless you get into more complicated operations. But this is the same task from observables done with CSP. So there's an output channel that we're going to be sending our commands on. And then the yield function, this is using JSCSP, which is the JavaScript CSP library. And you get the task data, you get the first problem info, and then you output a command. And then you just do a while loop to go over all of the other problem infos. And because this is a generator, every yield has the potential to block. So if our process that's doing the network requests to get the problem information takes a while, this process will block and wait for the next one. And I think the difference here between this and the previous code is interesting, where with sequential processes, you can work on your data in the order that you think about it. You don't have to deal with the whole stream at once. But on the other hand, with observables, there's a kind of elegance to thinking at a higher level, thinking about all of the data at once and how the functions that you're applying will transform that into a new stream. So it's just different ways of thinking about your data. So I came up with a bunch of different kind of attributes of these methods that I think are useful to look at. First, the number of values and the places that values can come from. With callbacks and promises, there's only one value and one source of those values. But observables and CSP can merge values coming from many different places, and a channel or an observable can contain up to an infinite number of values. The number of destinations is different. Promises, they cache their value, and so you can hand it out to any number of functions or clients that want that value, and they'll all wait for it. With callbacks, there's only one function that's going to be receiving the value. With observables, again, similar to promises, every client that receives it will see the same values. It multiplexes by default, essentially. In CSP, that's not the default. There are some cases where you want that, and there's an extra operator you can use to multiplex, but it's a little bit more work. And the underlying concept of CSP is one process talking to another process, and the exception is multiplexing. Error handling is another important thing in many cases with asynchronous work. If you've got a database call, a network request, where you want to make sure that errors are handled well. I put the little kind of warning sign next to callbacks and CSP because there's no first-class support in the types. With callbacks, there's the error-first way of doing things that Node has established, but there's no guarantee about that. Now, if you're using a type check language, it gets a lot. You can get more guarantees from that. And in CSP, a channel just holds a value, and that value might be a number, it might be an error. And so in the JavaScript library, the convention is to, if you're using a channel that might have errors on it, to check the type of the value you get out. Do isInstance with the result. And if it's an error, then you handle it. If not, then you handle it. Caching is another difference. As I said, promises cache, callbacks don't. Observables can. They don't by default, but there are operators you can do. But with CSP, the concept of caching doesn't really make sense.
Afternoon?
With observables, it does, because you're handing out this observable to many different things, and they might come in late in the game, and so you want them to see the past values that were sent through. With CSP, there is no late in the game, because it waits to send things until you take them. And also, if you hand out a channel to multiple processes without multiplexing it, they won't all see the same data. As soon as you take something from a channel, the other processes won't see it. They'll get the next value after that. I've talked about push versus pull a little bit, where CSP is different from callbacks, promises, and observables. And I think this is the key insight, where with callbacks, promises, and observables, the decision for when an event gets handled happens at the source. And it happens as a result of the transformations in the case of observables. But with CSP, the client can decide when they want that value. And they can coordinate, for example, between different streams. And if there's a specific order that's important, it's very fluid to do it. Whereas with observables, that's kind of an anti-pattern. If you find yourself wanting to ensure an ordering of different streams, you'll be fighting the framework a little bit. And that's what I've seen in the work that I've done with RxJava and ReactiveCocoa. Cancelability is something that observables do really well. So in brief, if you want to cancel an observable, you just unsubscribe from it. As soon as there are no more people, no more clients waiting for the values, the producer of this data, be it a network request, be it events, can just stop producing the data. And if it's an expensive AJAX request, it can cancel that as well. With promises, we're going to get cancelability. There's been so much discussion and controversy over how to make promises cancelable, because the new fetch API that is so nice to work with can't be canceled because it returns a promise. But things are probably moving in the direction of being cancelable, so that'll be all right. With CSP, not having cancel is a little bit less of a problem because it's pull-based, right? If you want the producer to stop doing work, you just don't ask for any, and it will be blocked. But there's still no solution for if I want it to actually cancel something that it started. But I think this is an API-level problem, and I wouldn't be surprised to see libraries solve this in the future. When I say private set, I mean who gets to send values. With a promise, as I can show here, when you're creating a promise down below, you get a resolve and a reject function inside of this closure. And no client of the promise can resolve it for you. You have to handle the resolving or rejecting when you create it. And it's similar with observables. The client of an observable can't affect the data that is on the stream, but with CSP, a channel is writable by anyone, which I think is a little bit dangerous. And again, this is probably an API-level problem. The Rust language has a primitive similar to CSP, and they have a sender and a receiver channel. And you can pass the receiver channel to other clients, and they can't mess with it. But that's an API problem. I also talk about mental overhead, because this is really important to consider when you're thinking about, okay, I'm looking at this problem, here are ways to solve it. How annoying is it going to be in the future to look at this? And callbacks are so simple, there's no overhead. Of course, it gets really complicated when you try to coordinate between different things. So that is overhead. But anywhere you see a callback, you know what's going on. Promises, again, with the debuggability, this will get better. But I've just spent a lot of time with observables, and I'll talk about this a little bit later, but there's a lot of work that you do in your head to try and figure out what the system is doing. And I haven't worked with CSP enough to be able to give a reading on how much overhead there is. So an interesting way to compare these things to each other is what does it take to convert from one system to another? If you've done anything with promises or then you've probably had to convert from a promise to a callback and back. And this is what it looked like. Converting between CSP and callbacks, I think will be interesting to you. In the top, we have you get past a function that expects a callback, and you want to return a channel that will produce the value. And so you create this callback function, give it to fn, and then when you get the result, you either push on the error or push on the result. As I said, there's no special handling for errors. And then going the other direction, you take the value off the channel and you have to check to see whether it's an error. And then you pass it as either the first argument or the second argument. I'm going to skip past this comparison, but this is CSP to observables. And the observables to CSP is very straightforward. The other way around takes a little bit more boilerplate, a little bit more work. Because observables have nice abstractions for doing one thing to the whole channel at once, whereas with CSP, you have to do the work yourself. You have to write the while loop. You have to kind of do all of the plumbing there. I'll go into some pros and cons as I see them. With callbacks, as I've said before, they're the least powerful, but that can be a benefit. There are a number of places in our Android code base where we are considering migrating from an observable to a callback, removing a place where we thought, oh, observable is so powerful, it'll give us all we want. In fact, it gave us more mental overhead when all we needed was a simple callback. So there are some trade-offs there, but of course, callbacks are very poor for coordinating between multiple things, and you have all this distributed state, and it's a nightmare. Promises, pros are over callbacks is that they're caching and guarantee a single value. And both of the cons are probably going away. So it's likely that in the future, promises will be the go-to for single value, single source asynchronous problems. With observables, I'm really impressed with all of the operators that you can do to a stream. The ReactiveX people have done a lot of work to figure out what are the transformations that you might want to do. There are, I don't know, about 100, maybe more, of things you can do to an observable. And so most of the time, when you're thinking, oh, if only I could do X, you just have to look it up in the documentation. And it works with many values. You're thinking at a higher level, and so it feels really elegant when you're making it. But the multitude of complex operators can also be a con, where you have to memorize all these things. And there's just the upfront cost of learning what these operators do, and especially how they interact. I've seen a lot of bugs where we didn't expect this operator and this operator, combining these two observables to do what it actually did. And so there can be some mismatch there between your mental model and what actually happens. And observables own the state of your kind of asynchronous state machine, but they don't provide much insight into what's going on. Now, Andre's going to talk tomorrow about visualizing your streams, and so maybe that'll solve all my problems here. But about a year and a half ago, I got really excited about Cycle.js and all these observables, and I wrote a little visualization library, but I ran into some problems, so I didn't continue. But all the time when I'm working with observables, I really wish, if only I could see what's actually going on. People talk about things being easy to reason about. I think it started with React. And when I say easy to reason about, I mean, how easily can a developer who's familiar with the tool but not with the project understand what's going on? Because a lot of things, we see them and we think, oh, that's really complicated, that's really unfamiliar, that's probably very hard. And the only problem is you just haven't gotten familiar with the tech. But what stands out to me is when you have a group of people that are familiar with the tech, and it's still difficult for them to understand that's going on, where there's probably something going on with the tech. And maybe it's dev tools, but it's so difficult to coordinate streams, especially when you're dealing with a stateful end product, right? We're working with UIKit, which is stateful, and there are some guarantees that we would like to have about the order in which these asynchronous things happen. That observables, we just find ourselves fighting it. And then the other part, pragmatically, is how hard is it to get to know the library? If that barrier is too large, then new people coming onto your team are going to waste a lot of time or spend a lot of time to speed. And maybe that's not something you're ready to devote. With CSP, like I said, I haven't spent as much time on this, but as I look into it, I'm interested more and more in doing a trial run and maybe converting some of our observable stuff into CSP to see where it breaks. But the pros that I see is that in normal code, you write sequentially. And CSP allows you to do that with your asynchronous stuff. It's very similar to async await, in that async await is an easier syntax to work with than promises, than callbacks. And CSP allows you to do that for multiple values, for these more complicated asynchronous situations. So I put together this nice chart for all of you. It is deeply flawed, and I tried to enumerate some of them. But hopefully you can ruminate on this when you're thinking about, okay, I've got this thing, it's asynchronous, what do I use? Thank you very much.
Awesome. Thank you. Let's look at the questions.
Okay, Redux Saga. I have not used it personally. My understanding is that it uses generators or async await. Redux Saga is the kind of thing that you would build on top of one of these underlying primitives. Cancel tokens. I am not going to get into that. There's a ton of politics.
That was easy. Okay.
Do you have some stickers? I don't, unfortunately. Sorry. So, which of the approaches do you use with React in Khan Academy? We haven't found any situations that are complicated enough where we have to coordinate between a lot of asynchronous things yet on the front end. This is mostly a problem that we've run into in our native apps. What do you think of Cycle.js? I think it's super cool. I've played around with it. I tried to implement my own version. And I think there's a lot of power in having everything defined in terms of observables when you don't have to interact with all of these stateful things and worry about coordination. Why would you use CSP in JavaScript while losing all guarantees from original CSP theory? I would like to learn more about what you mean by that. Is deadlocking a real problem in the CSP way of handling asynchronous code? Yes. So, well, I mean, real problem as in it's possible to write code that deadlocks. But if you are waiting on a channel that never produces a value, then you will die. And so in many cases, you want to include a timeout or other things. But deadlocking is something that will happen whatever you do in terms of observables. If you have a promise that never resolves, that's a deadlock. Can you comment on Aphrodite versus JSS versus styled components? Yeah, so Aphrodite is a library that we developed here at Khan Academy for doing JavaScript in your style sheets. And I personally love it. I use it in all of my personal projects. And the Aphrodite was developed to address our needs, right? We need to server-side render, and we want to have our styles co-located, but we also want to be able to use media queries and hover handled by CSS, not handled by setState or JavaScript. And so I can't speak well enough to the other two, but that's my take on Aphrodite. What is your preferred way of handling async? I go back and forth. As soon as promises get the property that they don't eat your errors, and async await is handled natively by at least the browser I use for development, async await will probably be my go-to for most things. But when you get to more complicated problems, like coordinating between many asynchronous streams that have multiple values, then go for observables or CSP. I already answered Cycle.js. What can you say about working with async things, specifically in React? I think this falls under the question about doing work in React versus doing work in plain JavaScript. There are a lot of headaches and bugs that come out of trying to do too much work in your React components. React components, by and large, should not have complex logic in it. As far as testing your React components, most of the time when you think, oh, this is getting complicated, I should test it, actually what you should do is tear out the logic, put it in a pure function, or in some kind of plain JavaScript function, and then test it there. And I think the same applies for asynchronous code. You want to be able to test that very well, and it should not be tied into your React components. It's not easy to test CSP code with branches and asynchronous operations. I think it is not easy to test asynchronous code in general. I would be surprised if CSP were harder to test than observables. I think it's just a difficult problem in general. What about testability? Just talked about that. Why native node modules? Do I still have time?
Last 25 seconds.
Okay. Why native node modules still don't use callbacks when there is native, they probably meant promises. And I'm sure that is just a backwards compatibility thing. And in general, the native hooks into whatever native land you have will just use callbacks because they're the simplest. They're the least opinionated. All of these other things can interact with callbacks seamlessly. But if they chose promises or if they chose streams, then you'd have problems if you wanted to expose an API that was different.
Awesome. Thank you very much, Jared.